Hello guys, welcome to the sixth video of Module 8, and here we are going to perform the data pre-processing on the training and testing data separately. So I'll be showing you that how exactly you can avoid the data leakage that we had talked about in the previous video. We'll be implementing two of the main data pre-processing steps. That is the encoding part and then the scaling part. Which type of encoding, which type of scaling, that's something that we'll be looking into in this video. So let's get started. So let us first of all understand that what is one hot encoding and then implement it on our dataset. So whenever we are having this kind of a text data, we need to convert this into a numerical data so that our models are going to understand it. So in the classification part, what we do is we convert our categorical output into the one hot encoding output. That is, for example, let's say we are having one column in our data called as island, and it's going to be very much difficult for me to pronounce this kind of names. I just call it as B, T, and D, for example. Okay? So we are having B, T, D as the island names. And if you want to convert this into a numerical data, one of the ways that we can do this is with the help of one hot encoding. And that's the kind of output that we get. So let's say if the island is represented with B, so wherever there is B, there will be 1. Everywhere else, there will be 0. Even if I had 10 different kind of categories, wherever there is B category, I'll have 1. On all the remaining 9 categories, there will be 0. Over here, there is only 3 categories. So in the remaining 2, we got 0. And it follows so on and so forth with for the T part and also the D part. So for the T part, we can see that wherever there is T, we are having 1 over there. And on the remaining part, we are having 0. And for the dream part or the D part, there is 1. And the remaining is 0. So this is exactly what we call it as converting this text data into its one hot encoding format. Given that this kind of categories exist, so wherever this category is, we have 1, everywhere else 0, 0 for that particular row. So we are having 1 row and 3 columns over here for 3 different classes. And because in our data also we are having 3 different classes, we'll be having something really very similar to this. So let's see how we can do this with the help of sklearn library. And to avoid the data leakage, just make sure that you're using only transform on the test data and don't use fit transform on the test data. Fit transform is only to be used for the training data as I explained earlier. And the same kind of description is also mentioned over here, that as we know that the Y data is a string type and our machines do not really understand this. So we are going to convert this into the numeric format, and therefore one hot encoding is what we are going to use from the sklearn itself. So inside the sklearn, we are having this pre-processing module from which we are going to get this one hot encoder, and we are going to create an object out of it. Over here, I'll just call it as one hot encoder and then run the code. After this, I'm going to use fit transform for the training data. Remember, this is the training data. Y test is completely different. So on the Y time, I'll be using encoding, that is the ENC, that is the object that we have created. Dot fit transform, that's what we have got over here. And then I'll pass the Y train as an input to this. So at the end, what I'm going to get would be the output in the format of 100, 010, 001, just like what we had seen earlier. So if I just run this code and look into the output, how is it going to look like? It's looking something like this. So I'll just convert this to a numpy array with the help of toArray function. Oops, I guess there is some kind of a problem. Oh yeah, it's because we have renamed, or I should say we have given a new thing to the Y train. It's no more stars, galaxies and quasars kind of format. So I just need to go up and get our Y again from the X train step. So yeah, over here I'll just run the codes again very quickly. And now I guess it will be fine. Yes. I'll just use toArray again. Now it's working fine. And if I run this code, now see, this is how it's going to look like, right? So I'll just cut this up and look into the categories that we have in this encoder that we have saved. with the help of categories underscore. And as you can see that it's first having the galaxies, then the quasar, and then the star. So over here, galaxy will be given the first column, quasar will be having the second column, and the star will have the third column. So if in our data we are having a galaxy, it will be represented as 100. If it's a quasar, it will be 010. If it's a star, it will be 001. We can go ahead and check this. I run this code. So it says that 001. So what does this mean? I'll just do the inverse transform with the help of the encoder and then check what is the output for this white range 0. So for that, I'll come over here and say that enc dot inverse transform on white range 0. So it is again giving us some kind of error. It is expecting a 2D array, yes. So I'll just convert this to reshape. We know that the y input should be 1 row 3 columns. So I'll just reshape it into 1 comma 3. And here now we can see that it belongs to star, right? So over here we know that star is 001 and this is indeed giving us the star. I'm just going to check the another example over here and it's giving us 100. And if I just copy this part and paste this over here, convert this to 10, we can indeed see that the first one belong to galaxy, 100 vector belong to the galaxy, and this is working just fine. So I hope that now the working of this one hot encoding is pretty much clear to you. And now that encoder already knows which category has one hot representation, we don't again need to fit the data on the test part. We can directly use transform for this. So over here, instead of using fit transform, I'll be using only the transform on the y test data. And what kind of error it is giving us? The transform does not exist because we haven't used enc over here. And there is one more thing that I just realized, that I need to convert this to array as well. So this works fine. If I look the data for the y test 12, it's giving us 010, and 010 is a quasar, right? So it should be a quasar while doing the inverse transform on the y test of 12. So it is working again the way we expect it to work. Now, after this particular step is done, that is with respect to the one hot encoding part, the next thing we are going to do is we are going to scale our inputs into one similar range, where if we are having different kind of ranges in our inputs, we might not have the optimal convergence, that is the fastest kind of convergence. So for that to happen, we are just going to scale out all the inputs into one typical range. The one that I'm going to use is in between 0 to 1. And for this, I'll be using a min-max scaler. All right. So for this, what I'll do is I'll simply go to the formula and show you that that's what is going to happen in the back end. That is how the min-max scaler actually works. I've taken this whole formula from this official documentation of how the min-max scaler works. You can read the whole documentation if you want to do it. And but yeah, that's what we are going to implement over here, where while doing the fit part, it's going to calculate the minimum and the maximum part for each and every column. After getting all of this data for each and every column, we are going to calculate this transformation with the help of this whole formula, and whatever is the output will be in between 0 to 1. That's how this formula is made. So how we can implement this? All of this explanation is given over here, that x means the actual value, then x min means the minimum value, then x max is the maximum value, min and max will be the maximum and the minimum value after the scaling. X scaled over here will be the value between the minimum and the maximum that we provide as a part of the input. Over here, the standard scale is the one that I had already explained, where you do the x minus mean over standard deviation. You can also try that out, but min max scaler is the one that I'll be using. We typically use the standard scaler when the all of the kind of outputs that we look into for the specific distribution, it follows this normal distribution or the Gaussian distribution. So that kind of part I did not really see while looking into some of my personal exploration, and therefore I'm going with the min max scaler. You can also go and look forward to this. If I scroll up somewhere, when we are having the whole data, I can click on this view recommended plots. Okay, it's going to generate some of the plots, and over here you will be able to see the complete distribution, and you will see that not everywhere it's following the normal distribution, and that's the reason I'm choosing the min max scaler for all of the columns. All right, so I'll just again scroll down and do the min max scaling part again with the help of sklearn library. So I'll be getting this min max scaler. You can choose to implement the standard scaler and look into the output. I don't really think there will be a lot of difference between the output, but still you can do it by yourself. Over here, I'll be implementing the min max scaler. So I'm going to create this scalar object, and the input values that I can give over here, if I look into the mini documentation, I can give the feature range over here. So feature range will be 0, 1. All right. Now I'm going to implement the fit transform for the X train data. Because it's a training data, I can do fit part. So for this, I'll just scroll down and create the scalar object, and now do fit transform of the X train data. And after this code cell is implemented, I'll also go ahead and do this. What is the minimum value for each and every column that is present after implementing the fit? Remember that this fit that we are having is going to calculate first of all the minimum and the maximum value for each and every column. So because we are having 15 columns, we'll be having 15 minimum values, 1 per column, and similarly 15 maximum values, 1 per column. So if I show you this kind of data over here, and all of this kind of commands, by the way, you can find it in this official documentation that is given to us. Just click on this and you can read about what all kind of things are stored in this SC. All right. So we have the data minimum, data maximum, and how many number of features were used over here. So if I run this code, so minimum values in all the features, there are the 15 features are this. Then the maximum values that we are going to get are this. And there are a total of 15 different features that we used to scale these values. So now, because using fit already on the X train data, we don't need to change this data minimum and the data maximum value for the test part. To convert or to scale the test data, we are going to use the exact same minimum and the maximum for each and every column that you are seeing over here to transform the test data. We are not again going to fit it. All right. If you just fit over there, then that's going to be a problem. And if I check about what is the minimum and the maximum value that we get after implementing the min max scaling, you can see that the minimum value is 0 and the maximum value is 1. So here is the X test data. I'll run that very quickly. Here is the minimum and the maximum data that we get on the X test after implementing the transformation using the minimum and the maximum values from the X train. And therefore, because of some kind of differences over there, we are not exactly getting this as 0 and this as 1. That's why this difference. If you had used the X test to fit this data and then do the transformation, again it will be 0, 1. But now this transformation is done in the same way that your training data had used it. So this is what is actually correct. All right. So over here, all this kind of same kind of points are mentioned over here. So yes, we are done with the data pre-processing. Now the next step in the next video, we'll be seeing that because the data pre-processing is also done, how we can build and compile the model with the help of TensorFlow and Keras framework. So I'll see you in the next video.